So far in Matlab, we've been able to declare specific variables using this method. Variable name such as x is equal to 5. Or variable y is equal to an array, 12 and 13. In this case, we tell Matlab to save these variables with these specific values. But when we get into logic, we're essentially going to ask Matlab about the data. We can say, is x greater than something? Is x equal to something or not equal to something? Does a combination of multiple conditions exist? So the first one that we can say is, well, does x equal to a specific value? And instead of using a single equal sign, we would use a double equal sign. So if we type x equal sign 7, we're not declaring x as being a new value. We're essentially asking Matlab, does x equal 7? Matlab's going to respond logically because we're given it logical expressions to evaluate. It's going to respond logically back to us. And it's going to do so in the terms of true and false, where true is logical 1 and false is logical 0. So when we hit enter and Matlab executes this code, it's going to respond with one of those two values. In this case, we know that x does not equal 7. So it's going to respond with false, or logical 0. It would look something like this. We can do the same thing with y. Does y equal to 12? Well, let's look at y real quick. We know that the first element of y equals 12, but the second element doesn't. Well, Matlab is going to respond for every single element within y. So because y is a 1 by 2 array, Matlab is going to respond with a 1 by 2 logical array. And each element of the logical response is going to be a 1 or a 0. So when we execute this line of code, Matlab should respond with a 1 by 2 array where the first element is 1 because the first element does equal 12. But then the second element will be logical 0 because the second element of y does not equal 12. Another example is to ask Matlab, does x not equal something? And we can do so with a tilde equal sign. Does x not equal 13? And if x does not equal 13, then the response would be true. It would be a logical 1. We could also ask if x is less than y. Same thing. Because y is a 1 by 2 array, the response is going to be a 1 by 2 logical response. So because x is 5, both of the values should be logical 1. We can also use values such as less than or equal to, or greater than equal to. But what if we wanted to combine multiple conditions? What if we wanted to know if the first element of y was greater than x and x was less than 2 pi? We can put all of those in a single line that Matlab will evaluate one at a time. And we can combine different statements using what's known as the ampersand or the or statement. The ampersand is this value here. When we list an ampersand in a line of code of Matlab, we're essentially stating that this is going to be a question, and we need both sides to be true. If either of the sides are not true, or both of the sides are not true, then the response from Matlab will be 0. So if we want to put a statement on the first side, we can say x is less than 2 pi, and y is greater than or equal to x. So we know that 2 pi is a little bit more than 6, so that should be greater than x, so this side should be 1. And we know that y being 12 and 13 are both values greater than x, so the response from Matlab should be logical 1. We can also use the or statement, which is a straight vertical line right above the enter sign on your keyboard. So it'd be shift \. The only difference between the and sign and the or sign is the or sign only needs one of the two sides to be true in order for MATLAB to provide a true logical response. If one of the sides is false, that's okay, as long as the other side gives a value of 1, then the response would be 0. So we'll say x greater than 2 pi. Now we know that this side is going to be 0. But y is still greater than x, both of the elements, so the response here should again be 1, 1. But what if we change the value of y? Let's show again that x is equal to 5. And we'll say y is equal to 2 and 13 instead of 12 and 13. And then we can say something like x greater than 2 pi and y greater than or equal to x. Well, we still know that this value is false, right? X being 5 is not greater than 2 pi. But then we have y greater than or equal to x. Well, because y is still a 1 by 2 array, we look at the first value here, 2. 2 is not greater than 5, so this whole statement is going to give 0. Whereas the second response is going to use y equals 13, which would give a response of 1. So the response back from MATLAB when we execute this line of code should be a logical array where the first element is 0 and the second element is 1.